Welcome to section 12.2. This is rational functions, and in this video, this is the first video of 3. You will be identifying excluded values and identifying asymptotes. So we're going to be looking at a lot of new information in regards to this chapter. We haven't done much like this so far this year. So let's begin. What is a rational function? Well, first of all, we know what a function is. It is essentially a graph that passes that vertical line test. Essentially, for every x value, there is a single opposite y value, and that sort of thing. So a rational function is a function whose rule is a quotient of polynomials in which the denominator has a degree of at least 1. So to put this in terms that make a little bit more sense, or at least make sense in what we're used to seeing, it is a function that looks like a fraction, and the variable is in the denominator. So we have a couple of examples here. A couple of these examples are y is equal to 2x, and if you notice, it looks like we have a fraction here, which is a quotient. There is an answer to a division problem here, and if we notice, there is also an x in the denominator, which is what we want. The variable is in the denominator. This other one, we have y is equal to 3 divided by 4 minus 2x. Again, the variable is in the denominator, and this looks like a pretty complicated fraction. Last but not least, we have y is equal to 1 over x squared. X is, again, in the denominator. That is our variable. And it, again, looks like a fraction or a gigantic division problem. So we're looking for quotients here. Now, there is a concept of excluded value when it comes to these sort of equations. Now, if we remember from slope dude in the past, essentially if the denominator of a fraction or a denominator of a division problem is 0, then we get a situation where y is undefined. It is literally where mathematics no longer makes sense. It no longer holds true. So if we are looking at this, we have an excluded value when the x value makes the function value y undefined. So we can think about this. Y is equal to 8 divided by x. And if x were 0 in this case, if x equaled 0, then that would make this whole situation undefined. And therefore, it wouldn't work. So essentially what we can write for that sort of this sort of problem, the excluded value is x is equal to 0. So x cannot equal 0 for that specific function. If we look at this other problem right here, what should x be, or what does x need to be if we want the whole bottom part to equal 0? Well, we can set up a little equation. We can say x plus 3 is equal to 0. We can subtract 3, and we get x would have to equal negative 3 for everything to be undefined. So our excluded value is x equals negative 3 for this particular function. Essentially, x cannot equal 3 or negative 3 for this function to really work. Most rational functions are discontinuous functions, and that means that they have breaks in the graphs. This occurs at those excluded values, so that's why we need to know what our excluded value is, because that is quite literally where our graph sort of starts and stops again. And at that point is where we can see some really interesting things happen. So our asymptote is a line that the graph gets closer to but never crosses as the value of the variable increases. An asymptote is also typically where the excluded values are. So if we have a rational function in the form y is equal to a divided by x minus b plus c, lots of letters here, the vertical asymptote is at the excluded value. So this is what tells us our vertical asymptote. And our horizontal asymptote is the stuff off to the side, y equals c. So here's an example. We have y is equal to 2 over x. Our horizontal asymptote, so essentially that missing c value in this case, is going to be 0. And our vertical asymptote, where this x is also 0. So essentially we have a graph that would have vertical and horizontal asymptotes at the axes, like right here. So let's look at another problem where this is a little more obvious. We have this other one where, I'll show you us all this. We have y is equal to x plus 2 plus 4. So our vertical asymptote is the x value that is needed for this bottom part of the equation to make all this bottom part to be undefined. So essentially where we're dividing by 0, which is not going to work out. So x would have to be, in this case, we'd say x plus 2 is equal to 0. So set this whole bottom part equal to 0. Subtract 2 from both sides, we'd have x is equal to negative 2. So our answer here is x equals negative 2. Our horizontal asymptote is just this plus c term, so our y is equal to 4. So essentially our graph that we could create for this, we'd have a vertical asymptote right here at x is equal to negative 2, and we'd have a horizontal one up in the air at y is equal to 4. So then from there we would figure out what direction this whole thing is going. Maybe it has maybe it's a graph that looks something like this. It could also be a graph that has everything opposite and looks something like this. Regardless, we have our asymptotes where things are not going to cross. So let's have some practice with finding some of these asymptotes and identifying those and that sort of thing. We have y is equal to 1 divided by x minus 6. Our asymptote for our vertical asymptote, so essentially our x value, x is equal to 6 because x minus 6 is equal to 0. We'd add 6 to both sides, x would equal 6. So we have a vertical asymptote there. We have a horizontal asymptote. Our y, horizontal one, our horizontal asymptote is going to be at 0 because essentially there is nothing there for our c term in this case. Let's do one more problem and then we will be at the end of this video and you can practice some. We have y is equal to 2 divided by 3x minus 10 minus 7. So our vertical asymptote is everything on the bottom. We have to say 3x minus 10 is equal to 0 and we'll be able to solve for our vertical asymptote. So we're going to add 10 to both sides and we get 3x is equal to 10. After that we'll divide by 3. And we have x is equal to 10 over 3. So our vertical asymptote is at 10/3. That is where this whole bottom part of the equation is going to be 0 and create an undefined situation. Our horizontal asymptote is at y equals. And right now we have, oops, I screwed up my iPad. Right now we have negative 7 there. So at negative 7 is our y asymptote because that is our essentially c term. So practice some of this on your homework. See how it goes. If you have any questions, as always, you may text me or call me or whatever you need to do. As well, you could always talk to your friends or watch a Khan Academy video. I hope you have a great day, and be sure to watch video number 2 and number 3 to finish up your missins. Thank you so much. Bye.